Intro talking about block randomization stratification in Excel. Let's assume you have two interventions, treatment 1 and treatment 2. You'd like to randomize patients to either one. However, you'd like to do it in blocks of 6 so that the randomization balances out every 6 patients. Well, to do this, you can set up an Excel spreadsheet, and you can have the randomizer, which I'll talk about in a second, and then a counter of those randomized to treatment 2 and those randomized to treatment 1. And so the first row, you would actually put in randomization between 1 and 2, so it gives you a 1 or a 2, and this cell asks, okay, is that cell, the randomizer cell, equal to 2? If it is, give it a 1 point. If it's not, it's 0, and likewise in this cell, if it's equal to 1, give it a 1. And that's your, these rows will be your counter, and I will use what's called a running total, so I will anchor these rows to C8 and D8, and as it goes down, it will just sum up as we're going along. All right, so to do this, the randomizer is the key portion, and so you need to have both a, you have to have the core randomizer, and you need to put it inside of a shell that's going to turn over every randomized block size. So let's look at patient 7, which is row 14. So first, the definition of the counter. So the counter is determined by asking the question, is the row above where you're interested? The purple box is row 14, so row 13. So A13, which is 6, divided by F4, the size of the block. If that equals, that is 6 divided 6 equals 1, so the integer of 1 is 1, and 1 plus 1 is 2, so you already know now you're in a new block. So let's go up to, let's say, row 4 here. Row 4, the counter would be 4 divided by 6, which is less than 1, so the integer of less than 1 is 0, so it's 1 plus 0, you're still in the first block. Now the core randomizer asks the question, first of all, is the running total in the 2's, the C column, and the 1's equal to 1/2 of the randomization block schedule. And the reason there's a counter multiplied to it is as you go down into block 2, block 3, block 4, block 5, you're still going to be summing anchored at C8, the top row. So therefore I needed to multiply the counter so that every time it was equal to, the sums would add up and equal to that number divided by 2, half of it, it would know that one of the two blocks, the 1's or 2's, have met their quotient for that block. So you want to know if it's equal to that. If it is equal to that, then you want to determine which arm was initially selected from the running total, because this is an OR statement, so it said it could be either the 2's or the 1's. So in this case, you would ask, are the 2's equal to the block divided by 2 times the counter? And if it's not, then you need more 1's. So let's assume in the very first section that in this case you got, in this case you have 3 1's in the first 4 patients. So by default, you need to have 2 1's in the 2 sections to make 3 in the 2's and 3 in the 1's. So that's how it would know once this filled up to 3, or this column filled up to 3, it would know to make the remaining default into the others. If no arm had reached the count of 3, then you would actually randomize, but you would then randomize between 1 and 2. So it would still be randomized generator, random generator for this cell if these didn't add up to the amount needed. So lastly, and I'm going to go back to row 7. Here, your counter has an if question. If A13, the row above it, 6, divided by the counter 6, doesn't equal, if the integer of that doesn't equal the ratio, then you would continue because you'd still be in the block. But the minute that is equal to the integer, you have now entered a new block. And by default, you're going to want to have the cell filled with rand 1 and 2 because you ran between 1 and 2 because you're starting over again. So if we look at this, here's a block of 6, and you can see that it's 3 and 3. You can look at the sum here, and it's 3, and if I was to bring it across, the sum, block of 6, would be 3. Let me just escape this. Here's a block of 6, the sum is 3, and if you go over to the right, the sum is now 6. If we come down to another block of 6, let's just choose from 19 onward to 23, 19 to 24. That would give you a count of 6, and the sum is 3. And on this side, the sum is also 3. You can see the sums are down here, the count and sum. So once you've done this, you can also take these rows, and you need to take at least 2 rows because row 9 and row 8 are not the same. You can copy and paste them. And if you've done that, and I've already done it, so I'm just going to unhide. Unhide. You can create it for another hospital, the same, and this is hospital B. Or you could say it is geography within one hospital or geography within one unit, beds 1 through 10 and beds 11 through 20 or so. You can also change your randomized block. Let's say we want to change it to 8. Now the purple turnover, the turnover spot is now going to be down here when you're on patient 9. But if you look here, you will have the counter says 8, and you have 8 patients. Now the counter says 16, and you have 8 randomized because I've taken both the 2s and the 1s. 8 times 4 would be 32. So let's go to 33. And if we go to 33, coming down here, the count is 8 and 4 patients randomized to treatment 2, and the count over here is 8 and 4 patients were randomized to treatment 1. So you have that for both. So lastly, what you need to do, because with randomization, every time you touch it, it changes, updates, you can copy, go to what I call frozen, paste special, first one is format, and then paste again, paste special, and paste values. And you now have, this is frozen, these are raw numbers. So now if you wanted to print out, you could hide these and just print out the colored columns between treatment 1 and treatment 2. Treatment 1 and treatment 2 color changes are basically, I used conditional formatting. Thank you very much. Hope this was helpful for you as well.